So, very good evening, guys, everyone. Right, very good evening. So, online participants, very good evening. Okay, right, guys. So, any doubts from the last session? No? Okay, right. Offline, any doubts? Basel's correction. Basel's correction. So, that is something utilize it to get that accuracy results while you're performing sample study. So, while you're considering performing analytics on a sample, what usually happens is at some point of time, results might be a little misleading. So at that point of time, to get that accuracy output, you'll be going with some correction, and that we consider it as Bessel's correction. Sir, Midi. Now is it clear, Lakshmi? Um, Online participants' voice is clear. Is it little low or is it loud and clear? Clear? Okay. Lakshmi, just try to increase the volume in your system. For others, it's fine. In your case, just try to increase the volume button. I guess it will be clear. Okay. Okay, right case. So today we'll do a quick recap of yesterday's session and then we'll proceed with today's understanding. Earlier, we started with a concept introduction to statistics part. So there we discussed about two variations in it, both descriptive statistics as well as inferential statistics. Both descriptive statistics as well as inferential statistics. In descriptive statistics itself, again, we discussed about two variations in it. Measures of central tendency and the other one is measures of dispersion. I think measures of dispersion also we discussed, right? Variance and standard deviation. Hmm? Hmm. 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 Population sample and last, I think, variance standard deviation. Hmm. I think that is where that Bessel's correction concept. Hmm. So along with measures of central tendency and measures of dispersion, we discussed about one more topic too called um, data types, right? So data types there we discussed about qualitative, quantitative. When you are referring with qualitative data, we are having nominal and ordinal, quantitative, discrete and continuous. When you're working with qualitative data, nominal and ordinal, nominal, no order, no comparison. Ordinal, there is a comparison, there is an order. Especially when you're working with nominal data. An example, no comparison, no order, like say for example, gender, color. Okay. But say for example, you're proceeding with ordinal, there is an order, there is a comparison. So I'll be proceeding with something like grades, right? Or say for example, pain. We just discussed about some examples. If you're considering about quantitative data, again, two variations are there, discrete as well as continuous. Discrete itself, we consider it as a whole number. We discuss some examples, number of mobile phones or number of pens, okay, whatever it. Or if you're, yes, number of cars. If you're considering again the categorical mix, okay, in the same numeric, quantitative, apart from whatever the variations that you are having, two variations, nominal, discrete. In the same way here, when you're talking about continuous, discrete, continuous, it's completely going to be a continuing number. A decimal can be included. So for example, age, weight, height, salary, sales, profit. These are all the things that you can consider for continuous data, which is again coming from quantitative data itself. So once the data types have been completed, we discussed about descriptive stats introduction. There we discussed about measures of central tendency and measures of dispersion. So today we'll try to focus more upon a concept called outlier, and then we'll go with a new topic called distributions. And especially today we'll try to target about a distribution called normal distribution, and then we'll proceed further. So what exactly we are going to discuss? I think earlier also we discussed about this topic outlier. Do you remember? So, so once again, we'll try to have a discussion on it. What is an outlier, guys? It's an extreme data point value available in the data set. Once again, I'm repeating, outlier itself is nothing but it is an extreme data point available in the data set. Now the question comes here is, if you are having any outliers available in the data, what we need to do? How you are going to handle those outliers? Simple thing. If you are having any outlier, you can either try to remove that outlier or you can consider replacing an outlier based on the requirement that you are having. So for example, the requirement itself is something genuine. You can think about, you can consider about replacing those things. But it is not genuine, then you can consider about deletion. Based upon the strategy, it will work. First thing first, again, for anyone still new with this concept, what exactly is an outlier? We'll discuss about it. Tanya, is there in systematic sampling if the population has 100 data points and there's a simple random sampling, we select 10, taking the example of COVID-19, if in DMAT, you only check the first person and allow the ninth person to go inside without checking, and then again check the 11th person and allow the next nine. Is it possible that the person we are checking doesn't have fever? Among the nine people we didn't check, someone might have it. So in this case, this lead to incorrect call. Yes, yes. See, Tanya, what usually happens is, okay, a good question. Okay, a question from Tanya. So we'll discuss about it 2 minutes and we'll go with outlier topic. So the question is, for example, yesterday we discussed about systematic sampling where you're selecting sample size n equals to 10. 100 individuals are there. Sample size n equals to 10. Every 10th individual you're just checking. But what are the remaining 10 customers who are entering where you're not checking the fever status, nothing? What if in case those individuals are having fever or even not? Yes, maybe or may not be. But what usually happens is if 100 individuals are there, if you're putting a sample size n equals to 10 every 10th customer, for every 10th individual, if you're checking, most probably you'll get the desired output. If every 10th customer, if you're checking and 10 customers, 10 individuals have been there in your sample, in the 10 individual sample, if say for example, 8 individuals are having fever, automatically you can consider remaining 80 individuals in that population might also be having fever. Why? Because in sample majority is there. But yeah, maybe may not be. Maybe the other individuals might be having or might not be having. So for that, the best thing that what I'll suggest is to cross check by taking some extra samples out there. Instead of taking a sample n equals to 10 by every nth position, every 10th person, now try to consider taking sample size every fifth customer or every seventh customer or every eighth customer. Like that, if you are trying to take a sample, obviously, there itself you are going to take considerations. Always remember, whatever the population that you are having, try to consider taking 4 to 5 samples to cross check your result. Based upon that 4 to 5 samples cross checking results, still you are getting that same similar output. Most probably your population result is something going to be exactly same. That what your sample result is providing. One sample is providing some output. Remaining 3 to 4 samples are not providing that output. Then your sample output, the first sample output might be misleading, yes. But if all 3 to 4 samples are providing the same similar output, then majority, almost 90% of the cases, the population output is also going to be same way. Clear? That is the reason I'll suggest you to take some extra samples along with it, one sample too. I hope it's clear, Tanya. Now, okay, right. Now, let's try to consider outlier. As I mentioned, outlier itself is nothing but it is an extreme data point available in the data set. Say, for example, if you are having a data set which consists of data points 1, 2, 3, 4, 5. Is there any extreme value available in this data? No, there is no extreme value. Everything itself is simple, consecutive numbers, perfectly fine. Good. There is no outlier. There is no extreme data point available in the data set. But now, assume that there is something called 1, 2, 3, 400. Now, is there any extreme value available? Yes. And this extreme value itself is 100. And now you are supposed to handle this outlier. Why you are supposed to handle this outlier is at some given point of time, if you are trying to perform an average, you'll not get that expected output that what you're looking for. See, consider there is a community. Yesterday also, I think previously also explained the same example. There is one gated community. In that community, say for example, 100 individuals are there. All those 100 individuals are there between the age group 40 to 50. 40 to 50. And if I'm asking you to perform average, somehow you will tell 45 is the average. Why? Because all 100 individuals are there between the age group 40 to 50, and the average, that is something you'll provide it as 45. But now there is the other gated community. Again, 100 individuals are there. Now, 95 individuals have been there between age group 40 to 50. How many? 95 individuals. But 5 individuals are there with age 100. Assume that 5 individuals are there with age 100. Extreme senior citizens. Now, if you are trying to perform an average for this gated community too, you will get an average somewhere like 58, 55, something like that. Now, is it manipulated or not? Obviously, it's manipulated. Why? Because 95 individuals, almost 95% of the data itself has been falling between the range 40 to 50. How you can say average is 55? Why? Because majority of the individuals are less than 50, right? How you can say average is 55? But that is possible. Why? There are extreme old age people. which are with age 100. If you are even considering them, the average itself is automatically tilted. So providing and treating these outliers is also very important, guys. If you are living this particular concept outlier, not putting that much focus, it's going to be a little tedious. It's going to be a little problematic. It's going to be a little manipulative while you're performing your average considerations. So these are all the things that you need to focus on while performing your analytic tasks. I hope it's clear till now. Now, what kind of outliers that you can generally see? See, if in case you are talking about some employee details, there is a data which itself is talking about employees. In that employees, there are multiple data points available. There are multiple data points available. Generally, the salaries have been provided in a normal ranges. Maybe there is an outlier. So for example, this outlier itself, consider it as a salary of a CEO of the company. Obviously, the salary of that particular employee is little high comparing with other employees. Yes, there might be an employee. So for example, office boy is the salary is little low comparing with all other employees. That is also a case with outlier. See, always remember outlier itself is nothing but it's an extreme high data point value. Outlier can be an extreme high number or extreme low number. It can be even a negative number or it can be even a positive number. So here, these are nothing but considerations outliers. Or say for example, you are working with something called temperature data, weather. So for example, the normal ranges have been provided here. 15 degrees, 18 degrees, 25 degrees, 34 degrees, 40 degrees. Somewhere like this temperature itself has been there. And there is something like minus 30, minus 35. Is it an outlier available in this data now currently? So this is what an outlier is. Any extreme value which is not something close to the normal data, we consider it as an outlier. Clear, guys? Say for example, there is a column like age column. There are some data points. Say for example, 25, 42, 41, 36, or say for example, 55, 41, 18, 17, 27, or 35. Like this data points up in the general data. And there is one number called 102. Maybe in rare scenario, it's a possible thing. There might be a person with an age 102. Obviously, I can able to say there's 102. Now, this 102 itself is nothing but it's an outlier available in the data set. Clear? But now you can say whether I can remove this outlier. No, you're not supposed to remove this outlier. Why? Because that is a genuine data point. There is a person who is survived till age 102 years. You need to handle that outlier. Why? Because it is genuine. See, genuine outlier itself is nothing but it is a possible value. Not genuine outlier itself is nothing but that is not going to be possible basically. If 102 is there, in rare scenario, there might be a person who survives till 102 years. But is there any person who survives like 120 years, guys? 120? Is it possible? No. Obviously, that is we consider it as not genuine outlier. Basically, that is not going to be possible. So for example, you are having a column called weight column. You are having some data points like 40, 60, 70, 90, 100 or 41 or 35 data points have been there. Immediately there is a data point like 180. It's an outlier, but it is a genuine outlier. There is a possibility of having weight 180 kilograms. It's okay. It's possible. But if I'm putting something called 380, is it possible? First thing first, it is not even possible. This is a not genuine outlier. And definitely you need to handle this outlier, guys. If you're not going to handle this outlier, it is going to be so problematic. Why? Because if you're, see, exclude this particular value for time being, guys. See, exclude this particular value for time being. What usually happens if you are going to perform average for only this particular data points? If you are going to perform average for only this particular data point, maybe the average you'll be getting something like in 60s somewhere you'll get in 60s somewhere you'll get that average. But now if you are considering this value as 380, and now if you are trying to perform an average, don't you think your average will be going to somewhere like 200? Now average weight itself you are getting 200. Is it basically possible? Logically, is it possible? No. But now you are getting average of 200. Why? Why? Because this outlier is there. And that too you are pretty much clear that there is no human with weight 380. That means it is manipulating you. If you are not considering it replacing or changing it, it's going to be really problematic. So always remember, if you are having any outlier available in the data set, make sure you need to replace it or you need to remove it. Removing an outlier, replacing an outlier itself is again a tedious process. Why? Because every time replacing doesn't work, every time removing also doesn't work. Why? Because if you are considering a data set which consists of multiple data points in first column, and in second column data points have been there, in for some other rows in the second column outliers have been there. Assume that here only 2% outlier is there. As if you are assuming this entire column as 100%, out of that 100% data, only 2% outlier itself is there. If you are removing the 2% of outlier, no problem. Why? Because still 98% of data is there. You can start working on it. Accuracy results will not come down. But in case, assume that if your entire data itself, you are considering it as 100%, and instead of thinking it as 2%, now it is considered it as 20%. Now, is that a good approach to remove that outlier? No. Why? Because if you are removing 20% of outliers, you are going to remove 20% of data. You're only left with 80% of data. And what you'll do with remaining 80% of data? Why? Because accuracy results will completely come down. And that is the reason, make sure every time replacing doesn't make a sense, every time removing the outliers also doesn't make a sense. Based on the requirement, we need to consider whether we need to replace or whether we need to remove. Or even take a consideration replacing an outlier. Definitely a possible interview question, guys, that you can expect. When you are having an outlier available in the data set, either you will go with replacing with mean or either you will go with replacing it with median. You'll go with mean or median. Always you need to replace any outlier with median, not with mean. Why? Because mean itself is sensitive to an outlier available in the data set. Say, if you are considering any outlier 1, 2, 3, 4, 90, is there any outlier available here? 90 is the outlier available in the data. Now, if you are going to perform mean, guys, mean, median, all these things are coming from which concept? Measures of central tendency. Now, what is the mean formula? Sum of all observations by number of observations. Mean you will tell 1 plus 2 plus 3 plus 4 plus 90 by 5. 100 by 5. 5 ones are 5 twenties are. Mean you are getting something 20. See, if you are having only 5 data points available in the data set, 1, 2, 3, 4, 90, how can you say 20 as your mean, guys? Why? Because out of those 5 data points, 4 data points are less than 5 only. Clear? 1, 2, 3, 4, 5, 5 data points are there. Out of these 5 data points, 4 data points are less than 5 only. How can you say, average is 20 if the case is 4 data points are less than 5? Clear? Got my question? And that is the reason you need to go with this approach, mean equals to 20. Clear? Now, if you are going with this approach called median, now what you are going to do? Say, for example, median itself will take exact middle value available in the data set. Clear? Okay. Now, if you are considering the same approach 1, 2, 3, 4, 90, you are having this approach. But in case if you are going with median value, the median value itself is nothing but exact middle value. We already discussed about it in measures of central tendency. And the data itself is in an orderly way, 1, 2, 3, 4, 5, ascending to descending. Obviously, the middle value itself is something 3. And now the median itself has been 3. Now try to understand where is 20, where is 3. Mean itself is very sensitive to an outlier, whereas median is not sensitive to an outlier. I hope it's clear, everyone. So any doubts, guys, online participants? Sir, how will we know if there are outliers in this particular data since we have a very large data sets by applying data filtering based on set by applying data filtering based on set. Yes, exactly, Tanya. See, usually what will happen is in case if you're working with a data set which consists of multiple millions of records, finding an outlier itself is going to be a little tedious. So what usually happens is there the domain expertise knowledge comes into picture. For the basic columns like age, weight, you can put a bound, you can put a frame. This is the minimum, this is the maximum. There is no value which is exceeding this maximum. There is no value which is exceeding this minimum data point. In these circumstances, in these scenarios, you can take a call. You can just provide something like, say for example, select star from table where age greater than 100. If in case any individuals were age greater than 100, those data points records have been updated rows. Based on that, you can take a call. Or say for example, you are working with something called weight. You'll put something called select star from table where weight is greater than 120, 130. Automatically you'll get that values. What I mean to say is if any value that has been falling, if you know that knowledge, you can proceed further. In case if you don't know, then you need to consider taking expertise from the domain expert working in that company. Remember, it's not like every time we'll be knowing what is the outlier value, what is the minimum bound, what is the maximum bound. What I'll suggest is if you're having a little confusion out there, in your company itself, there will be some person called domain expert. And why? Because usually what happens is in any company, the company itself is been serving for one particular client or one particular domain. Obviously, they need to take one domain expert. And there the domain expert will help you out. What is the range? What exactly is the minimum bound? What exactly is the maximum bound? Based upon their updations, you can consider their value and then you can consider how to approach those values. Okay. Okay. Sir, if it is genuine or not genuine outlier, we should have to replace. Depends. See, if in case the example that we discussed, if there is a value like 98, you need to handle it. You need to find it, no problem. But if you are having something like age of 150, you need to try to remove it. But if still the percentage of outlier itself is great, high, 20%, 30%, then you're not supposed to remove. You need to replace those things. So depending upon the requirement, you need to handle it. That is what I'm trying to explain. Okay. So what if the values is missing? What if any value? That we consider as null values. Again, the same thing. If you are having null values, again, you need to consider whether you need to replace it or whether you need to remove it. You need to take percentage distribution. See, if you remembered in Power BI, there is something called view tab, if you remembered. In view tab, column profile, column distribution. There, if you can see how many null values are there, right? How much empty data is there? Those all things have been provided. In case there itself, if you can able to see how much empty values are there, percentage will be provided. Based upon that percentage, you can consider whether you need to remove it or whether you need to replace it. If the null value, empty value percentage itself is very high, try to consider removing it. If null value percentage itself is very low, then consider replacing it. So depending upon the requirement. If the percentage itself is very high, don't remove. Why? Because if you are removing it, data loss. If in case the percentage itself is very low, then you can remove it. No problem. Or you can even replace it. No problem. Okay, Arjun. Now, when you're working with this outlier concept itself, we need to focus on a concept called skewness. Skewness. Skewness, two variations are the left skewed, right skewed. So for example, see if replace null values with zero, you can consider it doing so there, but every time again that might not work. Why? Because say for example, there is a column like age column. In that age column, null values are there. Is that okay to replace null values with zero? Why? Because logically speaking, there is no person with age zero. If say for example, there is a column called weight and null values are there in that weight column. Again, you are not going to replace those null values with zero. Why? Because logically speaking, weight zero itself is not possible there. So depending upon the requirement, you need to consider whether you need to take a call or not. Remember guys, always try to understand if you are having any column null values, every time try to understand when you are working with data, try to approach it logically. Answer itself will be in front of you. If you are working with any column or anything, try to consider it and proceed further. That's it. That is the only suggestion. Okay guys, clear? Now, when we are considering about left skewness, what does this left skewness mean? You are having entire data, there is an outlier available which is negative part, you consider it as left skewed. So for example, you are having a temperature that we discussed, the example degree Celsius centigrade, 10 degree, 20 degrees, 30 degrees, 30, 40 degrees. The general temperature itself has been falling in this range. But there is something like minus 40 degrees, minus 40 degrees. Now what usually happens is you'll get a curve guys. You'll get a curve like this. And here an extra stretch of line is there, right? A slant slope line stretch. This you consider it as skewness. And the skewness is left side or right side. And that is the reason you call it as left skewed curve. Or say, for example, there are, say, for example, there are salaries of the employees. So, for example, here it will be provided as 20,000 or 30,000 or 40,000 or 50,000 or 60,000, like that salaries have been provided. And here there is one salary which itself is ranging like 3 lakh. Okay, 3 lakh. Now, automatically, what are the curve that you are getting? The curve itself has been distributed here, and here you'll get a skewed curve here like this. And what are the extra stretch of curve that you are getting here? You call it as skewness. And what is the type of skewness that you call it as? Right skewed. Why? Because the skew that you are getting here is completely tilted towards the right side and you consider it as right skewed curve. Left side, if you're having a skewed, you consider it as left skewed curve. Any outlier left side, left skewness. Any outlier right side, right skewness. Simple requirement. Okay, just check this out, guys. Try to make a note of all these things in your own words. This on this topic, definitely, I guess you can expect multiple questions out there, especially if the interviewer itself is something more interested to target on statistics part. Definitely, higher the chances they'll pick this topic, outlier topic. Important. For that, again, functionalities will be there. How to point skewness. I'll explain that next part. In normal distribution, I'll try to showcase that concept, okay? How mean median mode will work. Scroll. But to handle multiple outliers if present in multiple columns of a data set, we need to do it manually, Atul. For every column, we need to check and we need to consider it doing the same way. And then if multiple cases have been there, then you need to take a generalized approach. Okay, now let's go with a new topic. Normal distribution. So what does this normal distribution mean? Okay, so to understand this, first I'll suggest you to quickly Google it and update me what exactly this normal distribution is. Based on that, I'll try to explain. Try to understand and try to explain in your own words case. Hmm? Hmm. Hmm. Okay. The normal distribution describes a symmetrical plot of data around its mean value where the width of the curve is defined by the standard deviation. Normal distribution is a way data is spread out. Most values are in the middle and fewer are at the ends. Normal distribution has a skewness of 0. Is it perfectly symmetrical? Right. Okay, nice point, Bhargavi. Normal distribution has a skewness of 0. It is perfectly symmetrical. We just discussed left skewed, right skewed data. Left skewed skewness itself is their complete left side. Right skewness, entire skewness itself will be tilted towards the right side. When you are working with normal distribution, there is no skewness available. It's a normal distributed curve. See, when you're considering about left skewness, you'll get a somewhere curve like this. If you're working with right skewness, you'll get a somewhere curve like this. But if you're working with a normal distribution itself is something categorized like this. Entire data itself has been spread in this way. And this we consider it as normal distributed curve. And let's try to conclude, let's try to understand it much more effectively. Let's try to have a curve like this, normally distributed curve. What usually happens is whatever the data that you are having, entire data itself is going to fall in this particular range only. Earlier, what's happening? Some portion of data itself is even spreaded in the left part, and some portion of data itself is something even spreaded in right portion part too. But now when you are referring with a concept called normal distribution, entire data itself is something available in exact middle part itself. Let me explain you what exactly this normal distribution means. The one example that you provided, height, height of the students available in the classroom. Or say for example, age. You are working with one age data, age column. Majority of the ages have been provided. All the ages, almost all the ages in that column itself is something available between this range only. If you remember, yesterday itself, we discussed about the topic called standard deviation, in which topic measures of dispersion. What usually happens is, let me introduce you with new functionality. There is something called empirical formula. Empirical formula. And what does this empirical formula will explain about us? The data that is going to be distributed is something falling in between the range 68%, 95%, 99.7% of data. What I mean to say is, if you are taking a curve of distribution, normal distribution curve like this, where you will be finding your average value somewhere here, right? Yes or no? Somewhere average you'll be finding here. Now this itself is nothing but one standard deviation, I guess. And this itself is nothing but two standard deviation. And this is going to be your three standard deviation. Agreeing with this point, everyone? Yes, obviously. Now what I'm trying to conclude here is, if you are taking consideration between one standard deviation and one standard deviation, almost 68% of data itself is going to be available. If you are going to consider the data which itself is available between 2 to 2, the range itself is going to be available between 95% of data. And between 3 to 3 standard deviation, almost 99.7% of data itself is going to be applicable here. And one important thing that you need to focus on here is, wherever the majority of the percent of data itself is available, there the curve itself is going to get a peak position. Yes or no? Where the majority of the data itself is available, there the position, the curve, the peak itself is going to skyrocket. Mountain curve you're getting. And don't you think this particular curve itself is resembling a bell curve, bell shape? And that is the reason we call it with an option. We call it with a name bell curve. Whenever you're working with normal distribution pattern data, the one common thing that you can able to access is you can able to see something called bell curve. And this is something how bell curves look like. And this is the empirical formula 68, 95, 99.7% of data. And what exactly it is trying to explain? Between one standard deviation to one standard deviation, you can able to access almost 68% of data. Between 2 to 2 standard deviation data, you can even you'll be able to accommodate 95% of data. Between 3 to 3 standard deviation, almost 99.7% of data itself is being distributed. Let me explain the same concept with some real-time examples so that you can easily able to connect. If you're working in any company, usually what happens? Majority of the employees are been falling under maybe junior level category, junior to sub-junior level category, and those salaries are been provided. Almost these employees are been falling, like say for example, 68% of category. Clear? Got my point? What I'm trying to explain? The majority of the employees are been falling between this particular category, 68%. Now, there are only few manager positions, team lead positions, yes or no? See, manager positions, team lead positions are going to be less, or employees, the junior level, fresher level employees are going to be less. Tell me one thing. Obviously, the manager positions, the team lead positions are going to be little less. And here, majority of the freshers, majority of the employees who are working, there the curve itself is increasing, guys. But once the seniority level itself is increasing, where managers or team leads have been coming into the picture, automatically the curve itself is little flattened. Why the curve itself is little flattened? Why? Because there the distribution is little less, right? Why? Because there the positions are very minimal. And that is the reason the data itself has been spreaded here. But how much percent out of 95% if you are removing 68%? So for example, 78, 88, 98, 27%. That means only 27% of remaining data. That means this portion and this portion. But if you are considering this and this, almost 95% is falling between 2 to 2 standard deviation only. But if you are going level away above hierarchy, maybe there are some positions like vice president, president. There almost the positions are going to be even minimal. Very less positions are there. Extreme high seniority level. And that is the reason almost the curve itself is also very flattened. And between 95 to 99.7, how much percent is there? Only 4.7%. Why? Because the positions are very less. Automatically, the curve itself is very flattened. And that is the reason this particular position, any data is there, the data itself has been falling. That means, in a nutshell, whatever the data that you take, almost 99.7% of data itself has been falling between 3 to 3 standard deviation itself. And 95% of data itself has been falling between 2 to 2 standard deviation itself. And 68% of data itself is available between 1 to 1 standard deviation. And based upon this particular requirement, whatever the data that you want to understand, you can understand. And now just a simple thing, guys. Are you getting 100% or 99.7%? That means how much percent itself is still left? 0.3%. That means here 0.1.5%, here 0.115%. Now, if any data which is falling here or here, you consider it as outlier. Got my point? If still there is any data which is not falling in this range, still you consider it as it's a complete extreme outlier. I hope you understood the concept, this how the distribution works, normal distribution. Online participants, everyone. Okay, right, guys. Now, let's try to have a discussion how normal distribution itself is deviated with skewed curves. Guys, whether you are able to, you're taking the notes, guys, parallelly, whether I need to wait 2 minutes or I can continue. Continue. Wait. Okay, try to complete it 2 minutes. Okay, okay. I'll wait, guys. 2 minutes. I'll wait and we'll continue. So slowly we'll go with some other concepts which might feel little tough, but continue. As I mentioned before starting with this module only, all students for SQL, Power BI, they'll enjoy, but when stats comes into picture, okay, they'll not attend the sessions. Again in Tableau, they'll join. But this is something important, guys. In interview case, see, only remember one thing. Tableau is again Power BI. That is another Power BI. That's it. They're also dragging and dropping those things. If everyone is feeling comfortable with the tool, that means their competition is very high. Okay. If you are feeling easy, definitely others will also feel easy with the same tool and same concept. So competition will be little high for it. Okay. But if something is little tough, everyone will think that this is something not my cup of tea, I'll leave it. There the actual part will be there. High package or high. That is the reason even if you see the statistics itself is something that you can feel it as a founding, that the foundation for entire machine learning part, deep learning part, artificial intelligence part. Trust me, maybe in future if you are considering that if you are going with any opportunities like so for example AI engineer, artificial intelligence engineer, deep learning engineer, deep learning specialist, there definitely the statistics will be there. And there you will find that importance, how important this statistics itself is. Very important tool, very important subject. It's not a tool, it's not a technology. See, machine learning, deep learning itself is something completely relying. The concepts are itself is something deriving from statistical concepts itself. Yeah, having some approaches in machine learning like min, max, scalar, normalization, standardization. You'll be having something called uh, feature scaling, feature selection, okay, feature engineering. All these concepts are again interlinked to your statistics only. In future, if you are thinking about to shift to some other careers in AI related space, there again these opportunities, the statistics will help you out. So this is something, it will be as a foundation that you can utilize in case if you want to shift your career with some other opportunities too. Okay. Even data analytics part also, see, descriptive statistics and inferential statistics is something that I explained. Descriptive statistics itself is something more than fine. For a data analyst perspective, descriptive statistics is more than sufficient enough. But still, I'm trying to explain that inferential statistics topic from the next class. It might be little different from the topics that we discussed earlier, but try to focus on it. What are the things that you are able to understand? Just understand it and try to research about and try to make a note of your own. Okay. Maybe in interview also inferential stats, they might not ask you any question, but as an add-on, try to learn those things. It will be helpful. Clear? Now come to the main point, how measures of central tendency itself is going to act on this particular concept. So, sir, the part that you mentioned at the end about 0.3%. See, what I mean to say is, If any data which itself is something not falling between the range 3 to 3, any data values points that have been falling out of the range, those we consider it as still extreme values. Something like this, and some values which have been spread here. Okay. See guys, when you're working with normal distribution, a curve like this you'll get. Whenever you're talking about measures of central tendency, what are the three variations in it? Mean, median, mode. What usually happens is you will be getting median value somewhere here itself. You will be finding your mean value also here itself. And you will be finding your mode value also here itself. That means all the three measures of central tendency values have been provided in this particular range itself. And this is what the concept is all about. But in case if you're working with left skewness, see, try to understand guys, very interesting topic. If you're able to understand it, you'll enjoy. In normal distribution, what I mentioned, almost majority of the data itself is available in middle only. If entire data itself is something available in the middle portion itself, obviously mean, median, mode, everything itself is available in middle only. But when you are considering left skewed, what does this left skewed mean? Outlier will be available complete left side and the general data itself is available here. Yes or no? Now, if you are trying to take a consideration of mode, what is mode? Most frequently repeated value. Now what I mentioned, wherever the majority of the data itself is there, automatically you'll get a peak position there. So is that okay? I can draw mode somewhere here. Now what is median value? Middle value, right? Somewhere I can take a middle value like this here. Yes. But now if I'm considering taking mean, now that mean will be considered here. Earlier you are getting mean here guys, almost middle. But now mean is sensitive here. You are getting here. Why? Mean is sensitive to an outlier. See, in earlier case, we discussed about it. 1, 2, 3, 4, 5, you are getting mean as 3. But you are having 1, 2, 3, 4, 50, 1, 2, 3, 4, 90. Now the mean is 20. Now that 20 is something shifting towards your 90, right? That means the 20 values towards the direction of the outlier 90, right? And here that is not a positive, this is a negative outlier. And that is the reason mean itself is something shifting towards your outlier position. And this is left skewness. And in case if you are having something called right skewness, you'll get something like this. And general data itself is available here and an outlier itself is available here. And now if you are considering a peak position, most frequently repeated value, you will consider here mode. And the median central value, you will take consideration of median here. And now the mean itself is something again provided here. And now mean why it is providing here, this is something sensitive to an outlier. That is the reason the value is provided here. And that is the reason I suggested you, if in case you are having any outlier available in the data, always take an approach replacing with median. Why? Because if 100 individuals are there in a gated community, if only with 5 senior citizens, extreme senior citizens, old age people, like they're in 98, 99, 100, with those 3 individuals, if you're considering average, automatically all the remaining 95, 97 individuals are there between age 40 to 50 only. But only with these 3 individuals, how you can say average age is greater than 50? It's a false statement. Manipulative. That is the reason you need to consider these things. In that case, even though if these 3 old age people, 98, 99, 100 individuals are there, if you are performing median, still you will get 45 only. Got my point? See here, if you are taking 1, 2, 3, 4, 5, what is the middle value? If you are having outlier included, what is the middle value? Still 3 only. Why? Because even though outlier is there or not, middle value is middle value only in median case. But in mean case, formula is changing, right? Sum of all observations by number of observations. So there you are getting something called 15 by 5, mean is something 3. But here you are getting 100 by 5, it is getting something called 20. Now where is 3, where is 20? But median, it's middle value only. Even though you're having outlier or not, the middle value is middle value only. So even though senior extreme old age people 98, 99, 100 individuals are there, still you'll take middle value, you'll get 45 only. That means average age that you can conclude it as 45 or 47, somewhere you will tell. But now average age you are getting something called 55. But 95 individuals are there less than 50, right? How you can say average is 55? So always remember, if you are having any outlier available in the data set, what is your answer? Median, not mean. So this is something you need to understand, guys. A very interesting topic. Basically, all this we need to approach it with some logic. Then you can able to do it in complete different scenarios, guys. See, statistics itself is something going to be completely based upon logic only. Okay, whatever the logic that you want to create, whatever the logic that you're having, always remember one thing, only one suggestion that I'll suggest you is whenever you are performing your analytic tasks, data analysis, always try to handle the data logically and ethically. That's it. Forget about the technical part, all these things. Technical things, all those things, everyone will do. Why? Because they will try to learn some functions, they'll try to learn some tools, they'll try to learn some technologies, and they'll start working on it. That is not the case. The main motto of performing data analytics is how you are going to approach the data. How you are going to logically approach the data. Whether you are going to approach the data logically and rationally or not. So these are the considerations that you need to focus on. If you are having any column like age or weight column, whether that makes any sense replacing that value with 0 or not in case null values are there, or in case if any outliers, extreme outliers are there, whether we can consider it removing it or not. Why? Because if you are removing those outliers, whether first calculate the percentage out there. If percentage itself is something greater than 10%, 20%, there is no meaning in it. Why? Because if you are removing 20% of data, what you will do with remaining 80% of data? And there are some cases where if you want to replace a value, 50, say for example, 10% outliers are there, 90% data is there. If you are taking a consideration of taking median value or average value of above 90% and replacing it with 10%, that makes some sense. But there might be some cases where 90% outliers are there, 10% data is there. If you are taking median or average for this particular 10% and replacing it with for 90%, that doesn't make any sense again. Why? Because here minimum data is there. From that minimum percent of data, if you are picking average and you are putting it for maximum, there is no use. Got my point? What I mean to say? So every approach that you consider, you need to think it twice, thrice. If this is the thing that I'm doing, how it is going to affect the data, how analytics itself is going to work. Based on that part, you can perform the analytics case. Okay. So any doubts, guys, today? No? Online participants, any doubts? So is it interesting or a little hectic, boring? Interesting. Okay. Interesting. Okay. Fine then. So guys, so tomorrow and after tomorrow, try to revise all the concepts, childhood remembrance. Huh? Okay. So I think in our schooling we discussed about uh, this statistics, mean, median, mode, cumulative frequency, frequency distributions. That I guess in ninth or tenth we are having these things. Hmm? Graduation also we'll be having. Hmm? Hmm. In MBA also it is there. Yes, that is what. So for schooling, even someone coming from statistics background, for them again entire 2 years, 3 years itself is statistics only. Yeah. No, Ramya, there is no session tomorrow because of real world. Yes, yes. Why? Because the main thing is there we learn functionalities, all those things. Here, it's we are applying the functionalities with applications, business case study. See, remember, whatever the things that we are dealing, working with here in statistics, everything we are having functions in tools, guys. If you are going with Tableau tool or Python programming language or Excel for the next modules after statistics, in all these tools and technologies, you are having integration, these things. So then we can start working on it. Okay. Just a minute. Okay. Okay, guys. So tomorrow and after tomorrow, I'll suggest you to have a revision on SQL as well as Power BI. So for Power BI, as I suggested, Workout Wednesday, and for SQL, as I suggested, there's a website called Mode Analytics. And for preparation, go with HackerRank. So try to utilize these things, guys. Okay. And on Monday, we'll try to again proceed with the distributions available in statistics. We'll go with what are the different types of distributions available. And after completion of these distributions, then let's try to proceed further with the inferential statistics introduction. And that inferential statistics might take again 2 days of time, 2 or 3 days. Okay. Uh, any exam or assignment? Mm. Okay. On any specific module? Okay. I'll plan it then. Okay. Or else, how many of you completed your hacker rank? One, anyone got 1 star? 2 stars you got? How many got 3 stars? Okay. So a small homework for the one who already got two stars or 3 stars. Try to make sure get 5 stars by Sunday. For the one who haven't started utilizing this application, try to get 3 stars. Okay, by Monday session. Make sure don't take that reference of answer section in HackerRank. Why? Because there the thing is there is a section called answer section. Don't go there. There if you are going, you can able to find all the answers what other users provided. So even it takes 10 minutes, 20 minutes or half an hour or 2 hours, try to understand the logic and try to utilize it. And still if you are feeling that so much of time waste, if I'm not proceeding further, then only consider going with that section, answer section, or else don't go with it. So for one who not started with it, try to get 3 stars. or if already someone started, got 3 stars, try to get 5 stars. Okay. So clear, guys, everyone? Okay, then website. Huh? Okay. So this is how the website mode analytics. Say if you're going with this basic level, intermediate level, advanced level. Based upon level also, you are having all the topics available. If you are picking one topic, say for example, limit clause, it will neatly provide you the entire text. You just need to read it and you just need to consume it. And here it will be giving you some syntax. Try to take a reference of that syntax, and just down to it will provide you some practice problems. That's it. Here you are having this option called try it out. Maybe it will ask you to create an account. Without any hesitation, just try to create an account. And there the code editor window itself will be provided. Just that means they themselves will be providing you the entire database data, everything. Try to utilize their own data and try to satisfy that problem statement requirement. Try to satisfy all the test cases. All the test cases have been solved. You'll get that answer output. And then in case if you got anything, see the answer. So you'll get some messages, congratulations messages. It's a little interesting. You'll once you are able to complete 2 to 3 pages. Say for example, you are completing select limit where 2 to 3 pages are completing. From next page only you'll understand how to approach, how to do. Very interesting, very easy. And I'm suggesting, right? I'll suggest the same website for almost everyone. It's very simple, easy to understand. And here, this is something you'll not feel it as again new. Almost all the topics are completed in our sessions only. So there is no such topic like you'll feel it is again new thing. Just go there, just try to enjoy it, complete each and every page. If you are sitting for 2 days, you can complete this mode analytics website. Trust me. Sitting for 2 days in the sense, I think almost you need to dedicate for 7 hours daily. That might not work, but put a target for 1 week and complete this website. It's a good website. Okay. Okay, then guys, let's again connect on Monday and we'll continue with the session. Okay. Okay, then bye guys, everyone. Good night.